Hello, everybody. Let's do some problems on the quick check. Oh my God, this is a doozy. This is number 6 on the quick check. This is projectile motion, right? We're talking trajectories, projectiles, all the kinematics behind them. Let's go. A student throws a ball horizontally at the rate of 40 meters per second, right? So that's my initial velocity in the horizontal direction. If the height from which the ball is thrown is 2 meters, that's the distance. How far? What another distance? How are there two distances? Well, check me out. We're not doing one dimension anymore. We're doing 2 dimensions, folks. We have this dude who throws a ball, and that ball is a projectile, and it follows a trajectory. How do we analyze this trajectory with kinematics? Well, how big is the cliff? It says that the cliff is 2 meters, right? The distance up and down is 2 meters. That's the distance up and down. It asks what's the distance this way, though. The distance left and right, not up and down. I don't know that. So the first part of this is filling out what we need to know. All right. And the very first thing that you need to do is create a little chart. And that chart is going to help me answer this problem. So I have two directions here. I have up and I have across, right? I have up and I have across. I am going to use green for up and down, right? So that's going to be the y direction, right? Like x and y on a graph, right? X and y on a graph, x and y. So y is going to be up and then x is going to be across. So what is my initial velocity in the up and down direction? Well, if the ball starts here, and we're just talking about up and down, it has no downward velocity. It's not going down yet, right? So initial velocity is 0. Do I know my final velocity? No, but I know that when it drops, it's going to fall to the ground, right? This whole time it's going to be falling to the ground. And I don't know that, but I know the acceleration down, up and down, is negative 9.8 meters per second, right? And I know the distance is 2 meters. Now, what do I know about y? The x direction, left and right. Well, I know that the initial velocity that it's thrown with is 40 meters a second. What is my final velocity? Well, I know that this ball is never going to get faster. It's going to get faster downwards, but sideways, it's never going to get faster. It's always going to be 40, right? Assuming there's no wind that blows it or whatever. And the acceleration is going to be what? 0, because it doesn't get faster or slower. It does get faster or slower up and down, but not left and right, right? Not left and right. And then what is my distance? I don't know. That is what I'm looking for. That right here is what I'm looking for, right? So how do I figure out this distance? Well, I could say, all right, so my distance is equal to my initial velocity times time plus 1/2 at squared. I can say that, all right, my distance equals, what is my initial velocity? 40. What is my time? I don't know my time. It doesn't tell me. Now, is there a way that I can use the up and down stuff, right, the green stuff, to figure out the time? Yes, there is. Because check it out. I've got initial velocity. I've got acceleration. I've got distance. Remember this equation? Acceleration is equal to final velocity squared minus initial velocity squared over 2 times the displacement, right? Let's plug it in. What is my acceleration? 9.8 equals to, right, and that's negative, is equal to the final velocity squared, which I don't know, minus the initial velocity squared, which is 0, over 2 times the distance, which is 2, right? So this right here is going to be negative, right? Because it's going down. I'm solving for the final velocity. So it's going to be something negative, right? Because my acceleration is going down, it's going negative. How do I figure this out? Well, I can do math, right? 2 times 2 is 4, right? So that's going to be 4. And I can multiply both sides by 4 and then square them. I can also go to Mathway, right? So I'm going to Mathway, and I'm going to put 9.8. Now I'm just going to know that that's negative. 9.8 is equal to my final velocity squared. I'm going to put x, right, squared, just to make it easy on the computer. Minus 0 squared is going to be 0, right? I'm going to put it anyway. And all that's together on top, right? And I'm going to divide that by 2 times the displacement. That's straight out of my kinematic equation. You see that? Right? There it is. Right off my kinematic equations. I'm going to hit enter. And I'm going to, oops, I'm gonna go back. I know D. D is 2, right? The distance is 2. And I'm gonna hit enter, and it's gonna give me 6.26, which is the root of 39.2. 6.26. That is what I just solved for. What did I just solve for? 6.26. That's my final velocity. 6.26. So my final velocity is 6.26. 6.26 in the negative, right? It's going down 6.26. Now, what can I do? Can I find the time now? You're absolutely right. I can find the time. I have to use another kinematic equation. What kinematic equation uses time with my acceleration, my initial velocity, my final velocity? What uses that? You should know that it's right here. Acceleration is equal to final velocity minus initial velocity over time t. Well, I know my acceleration is negative 9.8, and I know my final velocity is negative 6.26, and we're going to divide that, right? Or this is minus 0, right? Because my initial velocity is 0. Divide that by t time. How do I figure that out? Well, math, right? So I can multiply, this is going to drop out. That is not part of it, minus 0. So I can multiply both sides by t and divide this by 9.8. Or I can use Mathway. I'm going to use negative 9.8, right? So negative 9.8, because it's towards the ground, is equal to my final velocity, which is negative 6.26, negative 6.26, right? Minus 0 if you want, but who cares because it's going to be 0, right? And that's over time, t. And I can put t, the computer knows, divided by t, time. And we're going to solve for that time. And it's going to be, okay, sponsor. Thank you very much, sponsor. That's very nice of you. Thank you. Here it is. The time is 0.637 or 0.638, right? Let's use 0.638 in it. 0.638. 0.638. Let's do that. 0.638 is the time. 0.638. 8. Now, I have everything I need to know in the up and down direction. What do I need to know again here? The distance? Well, I've already set up my equation. I have already set it up. Let's do it now. My initial velocity, my displacement is equal initial velocity, which is 40, right, in this direction, times time, which is 0.638, 638, plus 1/2 times the acceleration. What is the acceleration left and right? 0 times time squared, which is 0.638 squared. Well, you should see that 0 times all this is going to be 0. Now it's just 40, right, times 0.638. And that should get us to our answer. Is it hard? Yep. Can you do it? I think so. Let's practice, all right?